Nathan Rogers put a comment on my YouTube channel where he says he was talking with Morton, and Morton mentions there is a loop-free way to do the Snail sort algorithm, where the Snail sort is basically to take a rectangular matrix and print, or get all of the elements as a single vector rather than a matrix, a single list, in the order as if you traversed it in a spiral, in a clockwise spiral. Right, nicely demonstrated by these two diagrams here. And he says that the solution immediately came to him, which is frankly unbelievable. That is fascinating. I have never had such ability in my life, but fair play. It looks good at a glance, but it has to take a minute to understand it. He says, I can't figure out how to do this well without a temporary variable. And I think this solution is less clear than a more direct encoding, implying that this is the direct encoding, but as far as I can tell looking at it, the only difference is that this version is assigning the number of rows/columns, because this solution, I'll tell you now, it only works for square arrays, square matrices. And the only difference I can see is that instead of using squad swapping close, which is to say the ravel of omega, the ravel of the right argument indexed by these indices, the only difference I can see for the most part is that he's using square brackets in this one. So not exactly sure what is meant by direct encoding there, but either way, I thought I'd have a little look, to see whether I could re-express this without temporary variables, or if that was even, a good idea or whatever, and also to see whether I could have a crack at the general case, which I did end up coming up with something, so let's all have a look at that. So here's what it does: 3x3 reshape 0 to 9, and you can see it prints out 1, 2, 3, 6, 9, 8, 7, 4, 5. And it works even with a larger array. So 1, 2, 3, 4, 5, 10, 15, 20, 25, 4, 3, 2, 1, 16, 7, 16, 11, 6, 7, 8, 9, 14, 8, blah blah. You get it, it works. Pause the video and check if you care. So, on the topic of, can we do this nicely without temporary variables? I'm not convinced that that's really necessary. Because to me, for the most part, temporary variables is just about, it's just don't repeat yourself for one-liners. In production code, anything that takes that. These days, the trend is people like to have, if there's an assignment, it's on one line. Don't do multiple assignments on one line for the most part, except for maybe in the case at the beginning of some function or something, you've got a few quite short definitions of constants, in which case, have those separated by diamonds or something like that. Or strand assignment, which is to say A, B, C gets 1, 2, 3, you've got 3 values, and they're all related in some obvious way, like that. But otherwise, I don't really have a problem with inline assignment and temporary variables or whatever. Other languages, make a kind of heavier use of variables in that sense sometimes. So it doesn't really matter. But one thing that did intrigue me was A, figuring out how this works, and B, why does it only work for square matrices? Can we make it work for any rectangular matrix? I will not be pursuing higher rank arrays. So, first thing I had to do is figure out how this works, and that's largely basically looking at it, seeing what goes first. For instance, this thing, am I getting the shape of this, or am I doing a reshape, and stuff like that. And you kind of scan it, you figure you're not going to need the beginning part mostly. And since this is parenthesized and you get a shape value at the end, you're almost certain this is a reshape. So this is the thing that's kind of interesting to look at first, since it's one of the first two things that get evaluated are this stuff on the right and this stuff in the parentheses, which then is used to reshape this stuff on the right. So the shape of that is 9. We'll look at that later. Otherwise, it's a bunch of descending integers with some multiples. And it took me a minute to clock this, but to figure out that the a that's being assigned is used to replicate. So a slash whatever. So if you look at the whatever, it's a bunch of positive and negative integers. A slash just repeats those that many times. So then it took me a bit of playing around and figuring out what was going on so that I could try and get a similar thing working with a 3x4 matrix, right? So a non-square but still rectangular one. What's the rules? What are the rules governing these little intermediate values? One thing that I don't think I would have thought of quickly at all is this part here, which is really the core of this loopless version. Actually, I'll take a small tangent just to show you the looping version. 3x4 reshape out to 12, which is to say, grab the top, right, and then for the next part, drop that top, transpose the whole thing, but I want the 812, I don't want the 59, so then rotate that, and then grab, and then put that back in basically. So once we run out, oh no, I saw a clever one that was like, if it's not 0, do more. Yeah, and that's 1 squad omega comma that. It's a shame. Single thing. Oh, right. No. Okay, well that wasn't the way I coded it anyway, so I'm not even going to bother. Right, so take the first one, catenate it with, oh yeah, and if we've run out of elements, then give me nothing. Otherwise, take the first one, catenate it with the same function applied to rotate, transpose, 1 drop. And this is a recursive version, but I think it's kind of simpler to understand because for every stage you basically lock the top off, then you do some rotation and you want to lock that top off. Right? So 1, 2, 3, 4, 8, 12 is the side of the 1 drop, right? 8, 12 here. So you just need to do a couple of a rotate and a transpose, or a transpose then a rotate rather, to get those numbers that were on the side on the top, so that you can use the same operation to yank it off. So I think it's like quite straightforward to understand in that sense, but it is loopy. I will name you Snail loop, maybe Snail naught. Snail naught is the looping one. Let's go back to this. So yeah, so the clever sort of crux here is this idea that this is this part here, if you look at all of this, it's describing the manipulation of the indices in some sense. In fact, even more so once you see the a slash. That is to say, we start here, we do 1 above, 1 above, 1 above. Oh, right, sorry. This works with the square matrix, so let's stick with that. Let's go back. Right? Start from here, it's 1, 1, 1, but then you have to do plus 1, 2, 3, plus 1, 2, 3. Right? So that's your 1, then plus 1 is 2, plus 1 index is 3, Then you want to go 3 numbers up, 1, 2, 3 to get the 6. Then you want to go another 3, 1, 2, 3 to get the 9. Then you want to go minus 1 number to get the 8, minus 1 number to get the 7. Then you want to go minus 3 numbers, 1, 2, 3 to get the 4. And then you just want to do plus 1 on the end to get the 5. And that's just, and then when you do the plus scan, those are the indices themselves, which in the case of a, a 3x3 reshape 8 to 9 happen to be the numbers that you care about. So you don't have to do any indexing in that particular case, but in general you would just use these as indices into the ravel of the matrix, right? You'd be like, ravel omega squared by enclose this guy, and that way you can even get, you can get the same thing working for non-numeric data in that sense, right? Or any numbers that aren't just the integers corresponding to the ravel order. Doesn't matter. Next point is to say that then, okay, so we've got this thing A. Can't do that. How are we going to make this work for non-square matrices? Well, the key assumption with this version is that the rows and the columns are the same, so if you take the first of the shape, it's the same for both parts. It's the same for the part of the algorithm where you care about the rows and the part where you care about the columns. What I'm saying is you can change this to make it so that the one part that is focused on rows deals with the rows, and the one part that's focused on columns deals with the columns. So in particular, what is this to do with? 3, 2, 2, 1, 1. Well, it's how much you replicate the plus and minus numbers here. Which is to say, this is to do with kind of what's called strides, I guess, of an array, where like each row to go to the same column in the next row is a stride of 4 in this case, 3 in this case. So say I actually do that with the number of columns, right, this length rather than the rows, then it's to say that, okay, first we want to go in steps of 1 across, then we want to do some number of steps of 4, so that's this index, which is a number 4, plus 1, 2, 3, 4 to get to the 8, plus 1, 2, 3, 4 to get to the 12. Then we want to do some number of minus 1s, 11, 10, 9, then we get here, then we want to do minus 4s. And this actually works kind of really generally, right? So let's do 5 by 3 or something. You want to actually see that to demonstrate. You want to do some number of plus 1s, A, B, C, some number of plus 3s, F, I, L, O, some number of minus 1s, N, M, and some number of minus 3s, J, G, D. And then plus 1 again, E, then some plus 3s, H, K. So the next part is like, so essentially you want to reshape this into how many times you want to do each of those steps. That's like you're going across, down, left, up, across, down. How many times do you do that for each part of that process? And can that be determined from the shape? Well, here's your answer. It's yes. And that is to say, it took me a little minute to figure this out, but here it's 1, 2, 3, 4, 5, 6. 5 by 3, do it 6 times. 5 by 7, 1, 2, 3, 4, 5, 6, 7, 8, 9. 5 by 7, do 9 times. Okay, well let's do 5 comma each over 5. Reshape each quad A. Okay, when you've got one column, you do it once. When you've got two columns, you do 1, 2, 3, 4. Ah, shit, my solution might not work, because I didn't do it this way before. When you've got 3, it's 1, 2, 3, 4, 5, 6. You've got 1, 4, 6. 1, 2, 3, 4, 5, 6, 7, 8. You've got 1, 4, 6, 8. 1, 2, 3, 4, 5, 6, 7, 8. 5 by 5 is 9. I realise now, I was confident about my the solution which I'm trying to sort of get towards, but now I'm less so. If you look at one where the shapes are the other way, one row, even if it's like 7, one row is 1, 2 rows is 1, 2, 3, 3 rows is 1, 2, 3, 4, 5, 4 rows is 1, 2, 3, 4, 5, 6, 7, and 5 rows is 1, 2, 3, 4, 5, 6, 7, 8, 9. So I had 1, 3, 5, 7, 9, and I thought you'd just calculate that based purely on the number of rows. Ah, maybe I'm not wrong. 1, 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. I was right. It's, yeah. So it's basically the number of edges you have to traverse is the nth odd number where n is the rth odd number where r is the number of rows, right? So, what was I saying? 3 by 4 reshaped quad A. So that's neg1 plus 2 times the number of rows, columns, rows, the last of the shape. Are you for real? You're telling me this is 7. It's not 7, it's 1, 2, 3, 4, 5. Oh, sorry. Number of rows is the first one. Idiot. So, so it's the nth odd number where n is the number of rows. Right? That tells you how many edges you're traversing. You know that you're going to be traversing edges in strides of either 1 or the length of the rows, aka the number of columns. And this is where you basically take 1 comma the number, the length of each row, aka the number of columns, do a nice little plus minus fork here, because you're going to be going plus 1s along, plus 4s down the edge, minus 1s back, minus 4s up the other edge. Right? And you take our odd number based on the number of rows, and use that to reshape the instructions. Now the last piece of the puzzle, which if you scroll up and take a look, is this. Literally the last piece of the puzzle is figuring out what A is how to replicate. And I know I sort of started from A and went on a big tangent, but you'll have to basically just forgive me, because that's how thinking works. So, this case, assuming that they're the same number of rows and columns, you want 3 1s, then 2 strides down, then 2 to the left, then 1 stride up, and then 1 to the right in our spiral. How do we get this generally? So let's look at our 3 by 4 again. We know what we actually want is 1 1 1 1 4 4 neg 1 neg 1 neg 1 neg 1 neg 1 neg 1 neg 4, 1, 1. So that's taking our 1, 4, minus 1, minus 4, 1, and doing 4, 2, 3, 1, 2. Can we get this from the shape? That is well, they're all modifications on the shape itself. So we start with 0 from 4, we just do the whole 4. Then it's the height of the matrix, which is 3, but minus 1, because we've already dealt with one row, that's 2. Then it's the width, but minus 1, because we've already dealt with a column, that's 3. Then it's the height, but we've now dealt with 2 rows, so that's 1. And then it's 2, because it's the width, but we've already dealt with 2 columns. I.e., it is to say, you take the shape, of our 3x4 matrix, reverse it because we're doing fours, we're doing along rows, then down columns. Then we get our famous odd number, because we know that that's how many edges we're going to traverse. And then it's something like 0, minus 1, minus 1, minus 2, minus 2. What's that? And there's our 4, 2, 3, 1, 2. Because we said, we haven't dealt with any rows yet. Dealt with one row, dealt with one column. Sorry, other way round. Haven't dealt with any rows yet, but we're traversing one row. We've done the first row, and we're going down the column. We've dealt with one whole column, and now we're going back along a row. We've dealt with the top and bottom row, now we're going up. 1. 3 minus 2 is 1. And then along one row we've already dealt with 2 of the columns, so 4 minus 2 is 2. And this is basically just to say 0, minus 0, iota there's our odd number. Well, it's -1 plus the number of steps. No? Oops. I can learn to type it. No? Sorry. Not iota plus the steps themselves. Am I right? Oh no, that is an odd number, isn't it? Yeah, that is the number of steps. Do you understand this? Did it before. Right. Let's just pop you there. You're gonna sink. Oh, sorry. That's not 5. It's not 5. It's -1 plus the number of rows. It's -1 plus the number of rows. Number of rows is the first from the shape. Oh, and you have to replicate that. There we go. Because you're always doing a row, then a column, then a row, then a column. So that's why it's 2 replicate. So that's where you can get the A from in a general sense. So now it's just a matter of putting all the pieces together, right? You figured out A. You figured out the steps here. So now you need to do this slash this, and then you can do the plus scan. So you need to replicate, and there you have it. So putting this all together, is to say that this is A, is it? And these are the steps, or what are they? Strides or whatever. We can call US since we decided not using it. And it's S replicated by A. That means don't need to assign A. Oh, is it not? Is that not this guy? This guy's not the 141. Oh no, you're different. Sorry. You're based on the shape. Reverse of the shape. Replicated that many times. So the last piece, the last bit really is just cleaning this up, right? I can take this whole thing, put you there, then do the plus scan, then do omega squad by enclose. Oh, what's wrong? Oh, it's the ravel of omega. Right, there's our general thing, right? 3x4 reshape squad A. That's A, B, C, D, H, L, K, J, I, E, F, G. And if we do it like 5x3 instead, we look at you. That's A, B, C, F, I, L, O, N, M, J, G, D, E, H, K. So the thing works, this is a general case loopless spiral algorithm, but it's got some repetition and stuff. Let's see what I pasted in the orchard. I pasted this, which is pretty close to what we've got here. I think largely this is, I was just using inline assignment, so this is the shape. The rows and columns, that's the columns. Are we ever using that again? Not really. 1 comma that, reshape by the first of the shape. Well, we already got the shape. The first of the shape is the number of rows. Then this is sort of the length, what do you call it? That odd number, the number of steps. Call it n. That's -1 plus 2 times first of shape, so that's n, so that can replace all of this. Oops. Reverse of the shape, which we already have. Then, not sure we do much about this, but the first of the shape again is the number of rows. This we need, otherwise it's the same. And is this what I wrote before, or is it better? It's 1 character shorter. Oops, let's always put them both. Because why? I think my new one's a bit cleaner. Where I see I've swapped them around. You see how I'll swap here. The new one's a little bit cleaner, but it's ultimately the same. So, to answer your question, no, I don't think you can do it nicer with I don't think any aspect of it gets nicer if you remove temporary variables, because temporary variables are just don't repeat yourself embodied, right? You need to use the same value twice, just name it, refer to the name. And then also, hope you get something out of how I tried to express the thought process from going from what Nathan showed me to a slightly more general solution via my own understanding of how that algorithm worked. And I think, well, I got something that works. That's all I really care about. So,